So we've talked about intercepts and we've talked about slope. We're going to put those two concepts together today to learn about the slope-intercept form. It's a way of writing the equation of a line that actually lends itself very well to graphing. In fact, I think once you get used to it, you'll find it to be the most efficient method for graphing that we've talked about in this particular section of the course. So let's go back to our favorite example that we've used, this 2x minus 3y equals 6. So in previous lectures, we have found that the intercepts are 3, 0 and 0, negative 2. And we also discovered that its slope is 2/3. Well, look what happens when we take that equation and we solve it for y. Okay, so we're taking our 2x minus 3y equals 6. I've put in bold there the changes that are happening in each line. So the second thing I do is subtract 2x from both sides. That gets me to negative 3y is equal to negative 2x plus 6. Then I want to divide both sides of the equation, which involves dividing every term, by negative 3. When I do that, now let me mention one thing. Notice we go from 6 minus 2x to negative 2x plus 6. The reason for that is because I want it to follow this slope-intercept form that we're going to see in a minute. Remember that a term holds on to the sign in front of it, so that's why the minus sign travels with the 2x. So it becomes negative 2x plus 6. After that, we divide everything through by negative 3. And we end up with, so let's see, we've got negative 3 divided by negative 3 is positive 1. And then negative 2 divided by negative 3 is positive 2/3. And then 6 divided by negative 3 is negative 2. Okay, so that's where all of those different numbers are coming from. So we end up, after we're just rearranging this formula, we're solving the equation for y. We end up with y is equal to 2/3 x minus 2. Now notice right there we can read off the slope of 2/3 that we found. And remember our graph crossed the y-axis at the point 0, negative 2. Its y-intercept, the value there, that negative 2, that minus 2 on the end, corresponds to the point where our graph crosses the y-axis. That is not a coincidence or an accident. This is the slope-intercept form of the equation of a line. If you have it in y equals mx plus b form, now m and b are just going to be constants, just like in our previous problem. M was 2/3, b was negative 2. So the slope is the m value, and 0, comma b is going to be the y-intercept. Now notice this is plus b. So our last problem had minus 2 on the end. So that's why our b value was negative 2. Okay, so in other words, the y-intercept is going to take on the same sign as the last constant there in our slope-intercept equation. Okay, so let's look at some examples of this. So let's graph 3x minus 4y equals 12 using the slope-intercept form. So to do this, we need to rearrange it in slope-intercept form. So we end up with something of the form y equals mx plus b. So to solve this equation for y, we need to get the y term by itself. To get negative 4y by itself, we've got to do something with that 3x. So I'm going to subtract it off here, which is fine, as long as I also subtract it over here. So I've got negative 4y. Now notice 12 minus 3x is not 9x. Remember that 12, those are unlike terms. It would have to be 12x minus 3x. So I'm just going to still have my negative 3x and then plus the 12. And then the next thing I want to do is divide by negative 4. Okay, now I could write this as dividing the whole thing by negative 4. But what ends up happening is I'm dividing each term by negative 4. So perhaps a more efficient way to write this is just negative 3x divided by negative 4 plus 12 divided by negative 4. Okay, so negative 4y divided by negative 4 is just 1y. Negative 3 divided by negative 4, negative divided by negative reduces to a positive 3/4. And then 12 divided by negative 4 is negative 3. So this tells me that my slope is equal to 3/4 and my y-intercept is going to be 0, -3. Now, how does that help me graph? Well, I have a starting point. I know one point on the line is that y-intercept, 0, -3, so I can graph it right down there. And then remember the slope, that 3/4 is rise over run. So to get to my next point, I'm going to go up 3, I'm going to rise 3 and run across 4. So going up 3 gets me to the origin, and then to the right 4 gets me here. And there we go. There's the equation of the line. Now, sometimes, like if our y-intercept was way up here, we might need to go down instead. So let me point this out. 3/4 can always be thought of as -3 divided by -4. Now, why would you ever want to do that? Well, again, starting at our y-intercept point, we could also go down 3 and to the left 4, and that's going to get us right over here. It's still going to get us to a point on the line, and the same line, in fact. Let's look at a second example. Let's take 2x plus 5y is equal to 10. Again, we want to solve that for y. Got to get 5y by itself, so I'm going to start by subtracting 2x from both sides of my equation. So I get 5y is equal to -2x plus 10. And then I'm going to divide every term by 5. And so I get y is equal to -2/5 x plus 2. So here my slope is -2/5. Now it's a negative slope, so I know it's going to be generally going downward as we go from left to right. And my y-intercept, it crosses the y-axis at 0, 2. Okay, so there's my starting point. And then the slope. I have a negative rise value. If we have a negative rise value, we're going to go down 2. But then our denominator, they're not both negative, so we're going to go down 2 and to the right 5. So down 2 and to the right 5 gets me right over here. And there is my line. Okay, so we've got a negative slope value, so we see that the line does go in that negative sliding down direction. 2/5 is a rate, it's less than 1 and everything, so it's not going to be a particularly steep line, which is what we see. So again, just by rearranging the equation that we're given, we can put it in a form where we can just read right off of the problem the slope and the y-intercept, and that's the only two pieces of information that we really need in order to graph the line.